So I bought myself a Media Blast cabinet, did a bunch of research on the type of media and that I want to use for what I'm going to do. I think I got it figured out. I did 3 different soldering techniques here, brazing techniques here. Primary reason I bought it was for a complete another project that you guys aren't even going to see yet. But this tube came into my life here recently. This is a 4CX 15000, I do believe, or a 10, most likely a 15. This guy had 4 giant Rotron blowers blowing air up through the socket, but the chimney stopped about an inch below the bottom of the tube. This anode looks like beat down garbage. And this is what we're really here to talk about today. This anode just looks like beat garbage. But this tube, believe it or not, is still at full output. Now, the tube is so corroded, all this pitting, apparently there was pigeons that lived in this barn that this guy had this amp in. And there's some pigeon poop that had fallen on here over the years, and the guy just went on running the amplifier, and it totally effed off the dome of this tube, right? The top bell, this portion of the tube. This is really pitted, like bad. So I thought, this would make a good practice run for me. I got to Media Blast all this off of here anyhow. Most of it's a 2-stage process when you do these, like 3-stage, 4-stage. First stage is to clean this up to the bare nickel cooper and the steel. This ring here is made of steel. Okay, well, I've got to do this on the final project, which this plays a part of. But for you guys today, what we're going to do is we're going to Media Blast this down, and then I'm going to nickel plate the cooper nickel, and then I'm going to silver plate the anode and make it look all pretty again. So the first step is to go get all the corrosion and crud off of this thing, which we're going to do with a very, very soft media, and this is going to take forever, but it's a good learning experience. The idea is to make this tube look brand new, short of this pitting bit here. There's nothing I can do about that. And we're going to quietly hope and pray that as I'm Media Blasting this area, which I'm going to be very careful of, that I don't overdo it and end up causing a little pinhole and cause us to lose vacuum, because this tube is still good. Filament volts are good. High pot tested to 15 kV. Very, on the megameter, very low, very, 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 very low resistance. Or, incredibly high resistance. So it tells me it's still a vacuum on the inside of this tube. And this is me teaching myself, so I thought I'd let you guys come along, as I think it'd be fun content for you all to watch as I go through this process. So, air compressor just clicked off, the sun's going down. I want to go out and see what this looks like after I shoot some media at this. And I might end up having to change media. We're teaching myself here. There's more to this than you guys know. I am stoked about this. That whole joint was nasty and black. This is one form of high temp silver solder. And then when we rotate this around, this is another form of abrasement material that's here, this joint here. And then there's another one that's here. Okay, so you got to be very careful what you introduce into this environment. Like, you don't want to we can't use lead, right? Because then lead interacts with the electrons that take place in here, and there's a whole bunch of field bombardment and stuff that goes on, and there can be ionizing problems that take place. But I wanted to be able to see how this joint cleaned up, and then the inside of the bell. And after seeing this, I'm really encouraged. I think I got the solution to my problem. Boy, it took a lot of research to get here and a lot of time in reading. But that is our abrasement material that we're going to use for sure after looking at these joints. Now I understand how they put this together. So they would have a giant jig that would hold all these little fins. These are each little fins, and they're individually attached to the anode dome itself. And the flux that they, not the flux, but the abrasement material that they put on here to achieve that, when they put this all together, they do it in a hydrogen furnace. So everything can come up to the same temperature, and then everything can go back down at the same temperature, and they do it in an oxygen-free environment. It helps an awful lot. The only reason they do that is it helps an awful lot with the cleanup process. Okay. Boy, that cleaned up really pretty. This was just done. So even the media that's inside the Media Blast cabinet was specifically ordered to work with the nickel cooper that the tube's made out of, so it wouldn't erode it. But so it can't be anything biological based, right? So it can't be like walnut. I can't use walnut because then little bits of walnut on a very small, we'll say microscopic level, will impregnate themselves into something. So it's got to be a glass media, something that is a neutral. So once then I can go and I can dip this in an acid bath and then wash the thing, and I'll have just a pure straight nickel cooper exposed. But to see how little it eroded this lip here. All right, let's go clean up that other anode. So we're here at this day because I've had somebody tell me no. Okay, I've had two people tell me no. And the problem with these two people is they think of standards, because that's the world that they live in. They think of a standard of commercial transmission equipment standard. Like, there's no way this tube would ever get rebuilt. No way. The anode is too far gone. It's too rough. And there's no way that this would get fixed. They would, just by visual inspection alone, reject this anode, just this portion of the tube. So therefore it would be into the F it bucket. Me personally, I look at things differently. My standard is a little different. I mean, who's to say that I go through all the process of stripping this down, and then I go through the process of etching it, plating it, washing it, and then silver plating it, and then I put it in something that is personally mine and let it run the rest of its life, which there's still a ton of life left in this tube until the end of time, right? But if I sent this off to get rebuilt, they're just going to look at it and go, this won't meet our standards, and then it automatically just gets dejected. I have another tube that has failed, and I've had several people tell me no, and then I had one guy just basically try to steal from me. Anyhow, it motivated me. I'm like, okay, I look at things as their sub-assemblage of parts. It comes from everything I've ever done in my entire life. Growing up incredibly dirt-ass poor, and recognizing that if I wanted to have anything nice, I had to figure out how it was, take somebody else's junk, take it all apart and look at it as an assemblage of parts, figure out which little part was broken, then put it all the way back together and clean it up and then restore it to where it was nice again. Well, you know, my dad, when I was younger, had a shop that I could go play in that had a Media Blast cabinet and a Heliarc machine and band saws and every box break and every other kind of thing that you'd ever need to be able to create anything. Okay, I grew up in that environment, and so far those skills have paid off dutifully, I do feel. You guys get to enjoy them. Okay. I ran out of sunlight. I've still probably got another hour worth of time spent on this thing, but what I have here as a result, to me, is very encouraging. This poor tube has just been beat to death. Bing, 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 bing. It is what it is. The gray area is steel. The whiter areas are where the silver was still attached and the nickel plating was still attached. Now there's some other stuff here that I've got to clean off, like there's still a little bit of residue left here. This This cleaned up amazing to me. Don't get me wrong, that's a lot of pitting, that's a lot of erosion, but it's still holding vacuum. The inside of the handles, like down in here, I gotta go back and I gotta clean up in here a little bit. And I gotta go back and I gotta work the fins. This is where the poo is at, the bird poo is at. Just coming through and hitting that. Okay, there's a little bit of corrosion on the top, 1/1,000,000th of the fin, but the rest of the fin is still intact. And it's still got good capture to the anode bell. So, I mean, I got to come back, I got to rehit this and clean this up and clean this edge up, clean this off just a little bit. But then I decided before I lost all the sunlight so I could see what I was doing, because I don't have a light in my Media Blast cabinet quite yet. Give me a minute. We'll have it there in just a minute. I decided I would come and see how well the porcelain, the ceramic glass that makes up the primary insulation point between our G1, G2 ground ring and the anode. I just want to come see how this would clean up on the bottom side. So I cleaned up just in here. This is uncleaned up. This section here is uncleaned up. And this is cleaned up. So needless to say, what I've learned from this is that there is still hope for this yet. I got to clean up this little portion of the anode. I got some other stuff I got to do, but this is very encouraging. The number one thing I took away from this entire experience, and the reason that I bought the damn thing in the first place, the media cabinet, was this joint. To see this, and to see this joint here, and this joint here. That right there, money. I don't think you guys quite understand how money that is. That is, you'll see. You guys will see in the other video. But for right now, all we're focused on is this. This, wonderful. This makes me super excited. The fact that the inside of this thing over in here, where I applied all the heat, cleaned up so well, I can go back and I can really get in here and I can work and I can clean up the entire inside of this anode. And I took this seal to failure, heat temperature failure, and caused it to crack. And the fact that I was able to solder this back together, abrase it, pardon me, we're over 800 degrees, so it's abrasing. The primary seal material that's in this tube has a breakdown where it becomes soft and it's going to lose its ability to resist the 14.7 pounds of air pressure that's on the outside at sea level on the outside of this tube. Is at like 1300 degrees Fahrenheit. Okay. Well, where it melts is just a hair above that, and then where the nickel cooper actually starts to lose its integrity and then start to go liquid's not too far from that either. So to try and do a stopgap, I had to find another silver solder or another material that I could use as a filler in the joint through here that had a temperature that was only a couple hundred degrees below what the rest of the tube was held together with. Remember, I don't want these fins to separate away from the anode. This has all got to stay intact. So we're talking a couple hundred degrees worth of temperature. And I see why people, when they try to rebuild these things, they want to do it inside of a hydrogen furnace. It makes sense to me. Yeah, tube would have never been rebuilt. Okay. That makes me happy. We'll have more on this tomorrow. Okay, so we're gonna go stick this in the bath of cancer-causing juice. We're gonna see how well this turns out. I spent a little bit of time bead blasting the porcelain, got it all cleaned up and pretty. Let's go throw it in the tub of shit. Let's see what happens here. I think it's going to turn out pretty looking here. All right, gentlemen, here's our little update on what we got going on. So this is now nickel plated. It's got a thin little layer of nickel on the anode, except for in here in the center part. And this the steel ring that was all black, this thing is turning out beautiful. So now what I got to go do is, in theory, I could do a hard nickel plate on this now with a little bit more nickel dense solution, but I'm going to go ahead and I'm going to lay the silver on it. So we've cleaned the metal, we nickel plated it because the nickel's a little bit harder than the silver. And now we're going to do a very slow, very, very slow voltage and amp application of silver on the anode and a couple of the rings down here. And that should about seal up the nickel cooper. The hardest part is to get the plating to take in the center portion of the tube. So we'll see if we can make that happen. We'll be back. Well, I'm not going to bother to polish it because there's no point, but this is where we ended up. It's the exact same tube. This is the black as black could be anode. And this is hard nickel and then a silver nickel finish. So instead of just doing a pure, like what we think of as Grandma Sterling silver finish, I didn't polish the metal. I literally media blasted it, then put a hard nickel on it, and then put a silver nickel plate on it. But as you guys can see, the anode come out tits. Like it's not, I mean, it's legit tits and clean. And so's the stem. This thing was so gross. I was like, well, I mean, I can't stand to throw the tube away because I know the tube was good. It's just it wasn't cooled properly. So I don't know. But this is an experiment. This was just a test and a trial. I mean, the handle, this was effed off. The silver, the steel ring that's at the top of this thing. This tube's had a hard life, as you can tell. Literally looks like somebody took like a ratchet or a screwdriver and just went ding, 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 ding all the way around the anode. The tube's still good though, but it was coal black. Yeah, those are shadows here. This thing was coal black when I started. And to be able to get it back this far, I'm done. So, moving forward, now that I've demonstrated to myself that I can weld the inner seal, that I can weld our assembly point here together, I guess it's time to get on to the other project. They put this slit in the tube intentionally. There's a little cut here, and then there's another one right here. Remember, this is a different metal than this. This is nickel cooper, this is steel. So as the heat of the tube working expands and contracts and whatnot, we got to put an expansion joint. And how they deal with this on some of the smaller tubes like the, let's see here. I'll put a cut in them like so. Or they'll put a spiral cut. Like I had a guy call me just yesterday about a 1200D. And he goes, man, it's got this big slit down the side. Who did that with a Dremel? And I said, nobody. That's the way they come. So, okay, enough of this. I'm ecstatic with how this turned out. Now it's time to go fix the other thing that I've actually been building up to. I don't know if I've fixed it yet. Finish line's not there. The next step is, I guess, build a magnetic inductor and let's go learn ourselves about vacuum pumps and hermetic seal joints on nickel cooper. Gentlemen, I appreciate y'all tuning in. Just another day at the office. I had to shoot this on my Sunday, so I appreciate everybody. I'm just trying to make more content for y'all. Party on. Patreon.com. Yeah, Penta, XS, Siglent, MechMan, Bird, Coaxial Dynamics. Thank all of you. I'll see you guys. Just learning more about radio. Click, click, click.